Hello everyone. So this is a question from JEE Advanced 2025 paper 2. Consider a reaction A plus R giving us product. Okay, so this is important. A plus R giving us product. Rate of this reaction is measured to be K into concentration of A into concentration of R. Okay, important. As the start At the start of the reaction, the concentration of R, that is R naught, is 10 times the concentration of A, that is A naught. Important. Concentration of R 10 times the concentration of A at the start. Cool. The reaction can be considered to be a pseudo first order reaction with assumption. Okay, so pseudo first order reaction, important, with assumption that K into the concentration of R is equal to K dash. Okay, is constant. Due to this assumption, the relative error in percentage in the rate when this reaction is 40% complete, important, the relative error in percentage and when the reaction is 40% complete. Okay, and K and K dash represent the corresponding rate constants. Cool. The chapters involved is chemical kinetics. Okay, so for this reaction, that is A plus R giving us product, in which the order with respect to each reactant is 1, so the overall order of the reaction is 2. So therefore the rate law equation is, so you can write rate, the real or the actual one, is equal to K into concentration of A into concentration of R, and this is given to us. Yes, the rate is measured to be this. So therefore this is a second order reaction. But if one of the reactant is present in large excess, okay, example, one of the reactants might be a solvent. So when it is present in a large excess, its concentration will remain almost constant. Okay, very important. If one of the reactant is present in large excess, its concentration will remain almost constant. So in our question, it's R, whose concentration is 10 times the concentration of A. It is given to us. Okay. So it is given that the concentration of R is 10 times the concentration of A. So therefore, the reactant which is present in large excess in our question is R. Okay. So in that case, the rate of reaction will depend upon on the concentration of the reactant which is present in smaller amount. Okay. So therefore, in such situations, rate of reaction will depend only on the concentration of the reactant present in smaller amount. So that reactant in our case is A, right? So we have two reactants in our question. The concentration of R is 10 times that of A. So therefore R is the reactant which is present in large excess, and A is the reactant which is present in lesser amount. So the rate of reaction will depend only on the concentration of the reactant which is present in smaller amount, that is A. So the reaction seems like a second order, but it becomes a first order reaction. So such reactions which are not truly of the first order, but under certain conditions become reactions of first order, are called pseudo first order reactions. This is the definition, very important. Okay. So such reactions which are not truly of the first order. For example, in our case, it was actually a second order reaction. But since the concentration of R is huge, so the rate depends only on A. So therefore, it becomes a first order. So such reactions which are not truly of the first order, but under certain conditions become reactions of first order. They are known as pseudo first order reactions. For the given reaction, that is, A plus R giving us the product, the actual or the real rate, that is actual or the real rate, is going to be obviously K into concentration of A into concentration of R, right? But as we have mentioned that R is present in large excess, so therefore it will remain almost a constant. So therefore we put, and it is given also that K into R is equal to K dash. So therefore, substituting this in this equation, we get the rate that is measured, or the assumed, because we have done an assumption that the concentration of R remains constant. So therefore this is what we are going to write now is rate measured or the rate assumed. So that is going to be K into R we have taken as K dash and concentration of A. So what we did is, actually we are, when you have to find the actual or the real rate, we take concentration of R, we take concentration of A. But when we have to find the measured or the assumed rate, we assume that K is obviously a constant, and also R, since it is present in a huge excess, that is not changing. So we assume that K into R is a constant, which is K dash. So therefore this is the rate measured or assumed. Okay. In the question, they are asking us to find the relative error in percentage. So the relative error in percentage, the formula is mod of measured value minus actual value divided by the actual value into 100. So this is what we are supposed to calculate. Okay. So when the reaction is 40% complete, to find the real or the actual rate. So now first our aim is to find the real or the actual rate when reaction is 40% complete. So I will write down, we have A plus R giving us products. So at time t equal to 0, let's say that the concentration of A is X, and it is given to us that R is 10 times the concentration of A, 10x. So after some time t, obviously, some amount will be gone. That is, let's say that is alpha. So we'll be left with X minus alpha. And the amount of R that will be left with is 10x minus alpha, since both of their molar concentration is 1. Okay. And it is given to us that the reaction is 40% complete. So therefore, alpha is 40 by 100 of x, that is 2x by 5. So the concentration of A left will be x minus 2x by 5. The concentration of R left will be 10x minus 2x by 5. Okay. So therefore, concentration of A left will be equal to x minus 2x by 5, which is 3x by 5. And the concentration of R that is left will be equal to 10x minus alpha, that is 10x minus 2x by 5, which is 48x by 5. So therefore, since we have already found out that the actual rate is equal to K into concentration of A into concentration of R. Okay, so we will write that down again, that the rate actual or the real is equal to K into concentration of A into concentration of R. So concentration of A, we know that is 3x by 5, and concentration of R is 48x by 5. So this is the actual or the real rate. Now when the reaction is 40% complete, to find the measured or the assumed rate. Okay, so we have to find the rate that is measured or assumed when 40% reaction is 40% complete. So I will write down the reaction again, that is A plus R is giving me products. So at time t equal to 0, the concentration of A is X and R is 10 times 10X. And at time t equal to T, the concentration of A will be obviously X minus alpha, but the concentration of R we are assuming, since R is present in large excess, its concentration being 10 times that of A, its concentration almost remains constant. So therefore we are saying that K remains as 10x. That's the assumption that we have done. Okay. And since the reaction is 40% complete, so obviously alpha will be equal to 40 by 100 into x. So that is 2x by 5. So therefore, concentration of A left will be obviously x minus 2x by 5. That is 3x by 5. Okay. So we calculated the rate measured or assumed, if you remember. Yes. So that was K dash into the concentration of A. So I will write that down again. So rate measured or assumed is equal to K dash into concentration of A. And also K dash was K into the concentration of R. If you remember, we took K, which is a constant, that is the rate constant, and R, the concentration of R, as another constant. So therefore K dash can be written as K into the concentration of R. So we will use it here. K into concentration of R into A. So the concentration of R here is 10x itself. That's our assumption. And the concentration of A is 3x by 5. So this is the rate measured or assumed. Okay. To find the relative error in percentage, we know the formula. That is this one. So now we know measured rate, now we know actual rate. So let's find out relative error in percentage. So that is going to be the measured rate, that is K into 10x into 3x by 5 minus the actual rate, which was K into 3x by 5 into 48x by 5 divided by the actual rate, that is K into 3x by 5 into 48x by 5, and this whole thing multiplied by 100. Okay, so you can see k cancels, x square cancels, so we are left with 30 by 5 minus 48 into 3 is 144 by 25 divided by 144 by 25 into 100, and so this is 150 minus 144 by 25 into 25 by 144 into 100. So this gets cancelled, and so we are left with 6 by 144 into 100. So when you do this calculation, you will get your answer as 4.167%. So this is the relative error in percentage, 4.167. Okay, so the answer is 4.167%. Okay, thank you.